now. That was a sort of unique identity problem. All of them end up being unique, but they all have some common features as well. What I'd like to do now is determine whether or not this expression, secant squared of x minus tangent x times the cotangent of x, is equal to the tangent squared of x, is an identity or not. So I want to work through and determine whether the left-hand sides and the right-hand sides are equal. Now we can't pass things from the left-hand side to the right-hand side. We can't multiply both sides by something. We can't subtract the same thing from both sides. We're not allowed to do any operations like that. However, we can make the left-hand side look like the right-hand side. We can work to make the right-hand side look like the left-hand side, or we can try to get the two sides to meet somewhere in the middle. And in this particular case, I'm going to start with the left-hand side. It's usually in these cases better to start with the more complicated side because it has more places where you can do things. And one of the things I would encourage you to do is work to write things in terms of sines and cosines. So secant of x we know is 1 over cosine, so this is 1 over cosine squared x, minus tangent is the sine of x over the cosine of x. Cotangent is the cosine x over the sine of x. So we can see some nice things happen here right away. The cosines can cancel out, the sines can cancel out, which just leaves me with a 1 here. If we now go ahead and simplify things a little bit, I have 1 over cosine squared x minus, and now let's take and write this 1 with the common denominator of cosine squared, so we can combine these two terms together. So we have 1 minus cosine squared x over cosine squared x here. These have a common denominator, so I can combine these together. This looks like 1 minus cosine squared x over cosine squared x. And again, one of the things that goes off in my mind when I see this particular expression is the Pythagorean identity. We can see here that we have some sines and cosines, in this particular case just cosine squared, but whenever we see those combinations we should think of the Pythagorean identity. So let's just play with this for a little bit. I have the sine squared x plus cosine squared x is equal to 1. In my numerator in this expression I have 1 minus cosine squared x. So let me rewrite this trig function, this identity, so that on the right hand side I have 1 minus cosine squared x. So I have the same thing in these two places, which means I can do a substitution here and rewrite this as the sine squared of x over the cosine squared of x. So all I've done here is replaced 1 minus cosine squared x with what it's equal to, simply sine squared x. But now sine squared x over cosine squared x is simply the tangent squared of x, and that was what the right hand side of the original equation looked like. So we have now proved that the left hand side and the right hand sides are really the same quantity, just written in different ways. That proves that this is an identity. In terms of homework that I would like you to do in order to be able to follow and understand this, we will be spending a number of days on this particular assignment. For today, I would like you to look at page 434, problems 13 through 35 odd. Page 434, problems 13 through 33